Hello, I'm Patrick Niven from Siemens PLM Software, and I'm responsible for STAR ICE, the new add-on to Simcenter STAR CCM Plus for performing in-cylinder CFD simulations. While we continuously hear about the electrification of automotive powertrains, the reality is that the internal combustion engine will not disappear anytime soon, and in fact, will be a staple of powertrains for decades to come. That said, the push to downsize the internal combustion engine and the integration into hybrid powertrain platforms present many new challenges for engine development. And it is simulation that is key to addressing these challenges. With the latest release of STAR CCM Plus, we take a big step forward in STAR ICE with the capability to set up and run charge motion simulations by including the setup of liquid fuel injection and modeling the ensuing mixing process. Charge motion simulations allow engine manufacturers to improve combustion quality by controlling the mixing of inducted air with injected fuel, identifying and rectifying rich or lean mixture regions, especially in critical parts of the cycle, such as when the piston approaches top dead center and during ignition. This is especially important in today's direct injection designs, where the injection of fuel directly into the cylinder greatly impacts the bulk flow and turbulence level. The insight provided by simulation is more important than ever. Another critical role which charge motion simulation plays is the assessment for potential formation of harmful emissions. Again, ideally we want to achieve high quality mixing of fuel and air, which is notably challenging in direct injection systems where, at high load operating points, there is fuel injection during large portions of the engine cycle. Simulation tells us not only where we have lean and rich pockets of charge, but how fast the liquid fuel is evaporating, how much is impacting on surfaces in the cylinder, and if it's forming films or pools on those surfaces. All of these give indications of the magnitude of harmful emissions formation. If not mitigated, these will need to be cleaned up downstream of the engine using expensive aftertreatment devices in the exhaust line. While the ultimate in-cylinder simulation to address these concerns is one with full combustion and emissions models, these can still be relatively expensive to run. It may take significantly longer to get a solution from a combustion and emissions simulation than a simpler charge motion simulation. Additionally, over the years, OEMs have developed large databases for design guidelines based purely upon charge motion, using just the bulk motion inside the cylinder, metrics of fuel and air mixing quality, and levels of turbulence around the spark plug. This tells them whether combustion is going to be good or not, saving valuable engineering time, especially in the early design stages of a combustion system. So, given the value of these types of simulations, STAR ICE presents a collection of features to support charge motion runs, intended to make setup quick and easy, leaving time for the analyst to spend on engineering the solution rather than setting it up with lots of mouse miles and button clicks. From fast setup of typical multi-hole injectors, which can easily be customized for spray targeting, to quick selection of fuels, to the automatic setup of common post-processing outputs like liquid and vapor penetration plots and fuel mass tracking, STAR ICE has been designed to make the simulation setup easy and allow engineers to derive the most value out of their simulation process. Thanks for watching, and find more info on STAR ICE on the web.